Hi everyone, this is lesson 4.55 part 2, and we're going to learn a different rule for arithmetic sequences. So the rule that you learned in the last sequence is called an explicit formula. This formula can be used to find the nth term, which is a sub n, immediately. Okay, so explicit means immediately. But another formula is called the recursive formula. And it's done in multiple steps. So in order to know the recursive formula, we need to know the term before the term that we are trying to find. So here's an example. So if you're given the expression a sub n, the previous term will be a sub n minus 1. And then if you're given a sub n minus 1, the previous term, the one before it in the sequence, will be a sub n minus 2. If you're given a sub n minus 2, the previous term will be a sub n minus 3, and so on and so forth. Previous term will be a sub n minus 4. Okay, so we're going to see this notation in the recursive formula. So the recursive rule, so make sure you write this down, is a sub n, the nth term, is equal to the previous term, so a sub n minus 1, plus the common difference d. Now remember that n minus 1 is just a subscript, it's just notation. We're not actually taking a and multiplying it by n minus 1. Right, so a sub n is the nth term that you're trying to find. A sub 1 is the first term. Well, I guess we're trying to find a sub n minus 1. So is the previous term. N is the number of the term. So this could be the first, second, third, fourth, so on and so forth. And remember that n can only be a whole number. So it can only be positive and it can't be a fraction or decimal. And then d is the common difference, just like in the last rule. Let's do some examples. So write the first 5 terms of the given sequence. So for these ones, you're given the rule in recursive formula, in recursive form, and you're asked to find the first 5 terms of the sequence if you're given the first term. So here, we really just need to know how to read this rule. So this means the previous term, so you can find any nth term if you know the previous term, and then add 5. So 5 is going to be the common difference. So that means if our first term is 8, the next term will be 8 plus 5, so 13, plus 5 is 18, plus 5 is 23, plus 5 is 28. All right, so pretty easy. Here, our common difference would be negative 6. So if 2 is our first term, we subtract 6 and get negative 4. Subtract 6 and get negative 10. Subtract 6 and get negative 16. Subtract 6 and get negative 22. For part C, our common difference is plus 4. So you would start with negative 3 and keep adding 4. So 1, 5, 9, and 13. Okay, here's example 2. Write an explicit and recursive rule for the sequence. All right, so the easiest one actually to write is recursive because all you need to do is know the common difference. So here our common difference would be 2 because you're adding 2 each time. And then for the explicit rule, we'll need to know the first term, which is 2. So for recursive, we would just write a sub n equals a sub n minus 1, and then plus 2. Okay, by the way, in Edulastic, I'm having difficulties with their new updates because I can't seem to find the subscript notation. So you'll notice that in the previous Edulastic, instead of a sub n, I said a parentheses n, Okay, we're just going to say that they mean the same thing at this time because I've tried to contact them and they're not being super helpful. So we're just going to stick with this notation for now, but just know that I'm talking about the same thing. All right, but that's the only way I can figure out how to write, how to notate the a sub n, is to put it just in parentheses. The subscript notation is not working. All right, so anyways, there's the recursive formula, the explicit. Hopefully you can remember this from the video yesterday. It would be a sub n equals your first term plus the common difference, which is also 2, times n minus 1. Okay, for 19. For the recursive rule, well, your common difference, you're subtracting 4, so it'd be negative 4. Your first term is 19. So the recursive rule would be a sub n equals a sub little n minus 1, and then minus 4. So notice a sub n is like just a one term, or a sub n minus 1. And then explicit would be a sub n equals, your first term is 19 minus your common difference times n minus 1. And here, n minus 1 is not just a subscript notation, it's actually part of the equation. All right, and now we're going to convert the explicit rule to recursive, or the recursive rule to explicit. So here we have a recursive rule, and this number tells us our common difference, and we have our first term. So the explicit rule would be a sub n equals your first term plus the common difference 5 times n minus 1. Here we have recursive as well, and the common difference is 2. So the rule would be a sub n equals negative 5 plus 2 times n minus 1. For part C, we have an explicit rule, but it doesn't really look quite like an explicit rule because you don't see the n minus 1 part. Well, all this is it took whatever was the n minus 1 and it distributed the common difference d into the parentheses. So if you did, you would get d times n minus d. So whatever is being multiplied by the n is your common difference. So here, even though it doesn't look like the explicit formula that we use, it's just a simplified version of it. Okay, so that's simplified version of explicit rule. I just wanted you to be able to recognize that. Okay, so anyways, all you need to know when you're writing the recursive rule is the common difference. And since the 4 would be the common difference, since it's being multiplied by n, then that would be our d. So then recursive rule would be a sub n equals a sub n minus 1 plus 4. Right, and same thing for part D. So 3 would be the common difference because it's being multiplied by n. And so then it would be a sub n equals a sub n minus 1 and then plus 3. All right. And that's the most kind of questions it'll ask you if it gives you the simplified version. It won't ask you for the explicit rule. All right, so now I think we've already done this before, but just another practice is to find the nth term of the sequence. So we've got a sub 25, and you've got this sequence here. So if you're trying to find the nth term of the sequence, basically whenever you're trying to do a solving problem, you want to write your rule in explicit form. Okay, recursive rule is nice because it's simple, but it's not very useful to be quite frank. So here we would do the explicit rule. So we've got a sub n equals a sub 1. Your first term is 5. Your common difference is 6. So plus 6 times n minus 1. So remember, if you're trying to find the 25th term, you're just going to plug in 25 for n. So 5 plus 6 times 25 minus 1 is 24. And if you plug that in your calculator, 6 times 24 is 144, so that would give you 149. All right, and then for here, we would do a sub n equals 26, and then your common difference is negative 13, and you're trying to find the 17th term. You do 26 minus 13 times 17 minus 1 is 16. 13 times 16, order of operations. So 26 minus 208, and 26 minus 208 is negative 182. And remember, it's okay for the actual term to be a negative number, but the n can't be negative or a fraction. Okay, and then there's one other example that's going to appear on your Elastic assignment, and that is relating slope to arithmetic sequences. So I'm going to give you an example here that's not in this slide, but it comes from the homework. So let's say you've got the sequence 55, 55, blank, 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 115. And you want to find, well, you're basically going to fill in the missing terms. So in order to do this, what I want you to do is think about slope. So this would be your first term. Actually, if we go like x, y, this would be your first term. This would be your second, third, fourth, fifth. So can you take the information you're given and translate it into coordinates? So what about this one? The first term is 55. So that'd be 1, 55. And here, the fifth term is 115. So 5, 115. And then in order to figure out these missing parts, you would need to know the common difference. And the common difference is just your slope. So let's find the slope between these 2 points. So we would have 115 minus 55 over 5 minus 1. So 115 minus 55 is 60. And then divided by 4 would be 15. So 15 is your common difference. So that means you're going to just take 55 and add 15. So that would be 70, 85, and 100. So those are your missing terms. Okay, so that's what you're going to do for those types of questions. You're just going to translate them into coordinates and find the slope and then use the slope to figure out what the other terms are. All right. And I will do one more example, actually. Sorry if I'm making this video a little bit longer, but I'm going to do one more example with word problems that wasn't in the notes, but again, it comes from the homework. So here's an example. In an auditorium, you've got an auditorium, and the first row of seats has 30 seats. Okay, this is for the first row. And then each row behind the first row has 4 more seats. So this has 30 plus 4 is 34. And this has 34 plus 4 is 38. And so on and so forth. Okay, so you're taking the previous term and just adding 4 each time. What you want to do is you want to write an explicit rule for the pattern and solve the question. So the question is, how many seats are in the 25th row? Okay, so it's going to ask you to write out an explicit formula. Okay, don't just keep adding 24 or adding 4 25 times. Okay, we're going to write an explicit formula. So here we would write a sub n equals, and then remember it's the first term plus the common difference times n minus 1. So your first term is 30. Your common difference is 4 because you're adding 4 each time, and then times n minus 1. All right, so there's your formula. Now we're going to find a sub 25. So plug in 25. 30 plus 4 times 25 minus 1 is 24. And then if you plug that all in your calculator, you get 126. So the 25th row has 126 seats in it. All right, so that's an example of a word problem that you'll see. Another one could possibly be, you'll write your rule, but it will tell you the nth term. So let's say, for example, it tells you that the nth term, the 15th term is 300. And it also tells you that your common difference is, let's say, 8. But it doesn't tell you what your first term is, and it wants you to figure out the first term. So basically what you're going to do is plug all of this information in to the explicit formula. So a sub n equals a sub 1 plus d times n minus 1, and then solve for a sub 1. So a sub n is going to be 300. A sub 1 is what we're trying to find. Your common difference is 8, so plus 8 times n, where n is 15, minus 1. Okay, so follow just order of operations. 15 minus 1 is 14. And then times 8. Now I'm going to do 14 times 8. So that'd be 32, 8, 9, 10, 11, 112. So 300 equals a sub 1 plus 112. And then subtract the 112. And you get a sub 1. Your first term is, 188. Yes, that looks right. Okay, so 188 would then be your first term. Okay, so that's how you would do an example like that. So just basically plug in everything you know, write the nth term as a coordinate, plug it into n and a sub n, fill in the spots, and then solve for a sub n. All right, so I hope you enjoyed this video. You guys have a great day.